Okay, in this video, I'm going to show you how you make a wind turbine for your class. So you can see I've got my meter here, my motor inside connected up with the wires, a different propeller head, and with my hairdryer, when I blow it, you can see the different readings. Now what we're going to be doing in this activity is we're going to be comparing different propeller head, different turbine blades, to see which of these blades would be the right blade to put on our wind turbine to give us the best results. And we'll be doing that by conducting a fair test. Okay, so let's find out what we need and how we put it together. So this is our resource list that we need to make every turbine. Now the meter that I've got here, the standard digital meter, is what it looks like in its box, and there'll be a link to where you can buy that from, along with what its current price is. And you can see for this experiment we set it to the 20 volts reading. Okay, so we need the multimeter. You'll need a rotating motor, and again there'll be the link to this. You need a chuck block with 4 connecting points. You need your 5 different turbine blades, and again there'll be links to this, electrical tape, scissors, a screwdriver, an empty water bottle, a small neck one like this, like your sort of standard sized neck, because they fit nicely with the motor, and you need your 2 wires. Now normally you get your 2 wires with this kind of end on them, and all I have done is I have cut the end of the wires just using a pair of classroom scissors, carefully cutting down to cut through just the rubber, and then using the nose of the scissors pulling off the rubber sheath to relieve the metal, and then just twisting the metal into that point. So you can see that I've done that with both of these. They both had this end on the end, so again it was just a case of cutting it with your scissors carefully round just through the rubber sheath, and then pulling that off to reveal the wire underneath. So that's your kit list. There'll be a link to this in the document where you can purchase it from. Let's look at now how we put it together. Putting your kit together then is relatively simple, and you can decide for yourself, depending on the age and ability of the class you're working with, how much of this you want them to do, or if you just want the experience to be testing the propeller blades. So the trickiest thing, and the thing I would recommend that an adult definitely does, is putting the holes in the bottom of the bottle. Now if you're doing this yourself at home, an easy thing to do is just to warm up a skewer over the gas hob, and you can just pierce the bottle neatly with that. Or if you're not doing it at home, you're just doing it in the classroom, you can just use the head of a pair of scissors and carefully make that hole. Once you've done that, you're going to thread your wires through the bottle. Just keep pushing until you get them through and out the other end. Once you've got your wires through the other end, we're going to put them in the chop block. Okay, now it doesn't really matter which side we put them in the chop block, but we're going to put black in one and red in the other. Now you can see the way this works, that there's a little screw head there, and then underneath the screw clamps down on the wire. So we're going to thread that in, and then with our screwdriver we will tighten it up so it stays. Okay, so you can see I've gone ahead and screwed those 2 parts into the chop block just by tightening the screw head as shown. Now we're going to do the same thing again with our motor, but this time what we're going to do is we're going to line up the red and the black on opposite sides. So you can see I've got my black wire on this side, so I'm going to put the black wire of the motor on the opposite side, and then the same with the red wire. I've got the red wire here on the left, so I'm going to put the red wire from the motor in on the right hand side. Okay, so you can see I've got those bits set up there. So the black wire coming in from the motor on the opposite side from the black cable in the chop block, and the red wire from the motor coming in on the opposite side from the red wire on the chop block. Now what would be sensible to do at this point, before we push the components into the neck of the bottle, is just to test that everything works. So we're going to put a propeller head on top of the motor, we're going to plug in our wires into the meter, and we're just going to see that we get a reading. So let's try that just now. Okay, so I've gone ahead and set that up, and there'll just be a few points I'll point out just before we test that it works. The first is for yourself and for the pupils, you want to make sure that they're not pushing the propeller head too hard into the mouth of the propeller. So we don't want it to ram in on this, because we can damage the motor, or we can actually, when we've got it taped into the neck, it can end up rubbing on the neck of the bottle. So it really just needs to be sitting on and no more. And then for our meter, as I said earlier, we're wanting to have our wires connected to this first symbol. You can see the V and the ohm symbol there. And then underneath the COM symbol. We want to put those in there. Now you'll know you've got it the right way around because you'll have a positive reading, whereas if you have it the wrong way around, it'll show a negative reading on the meter. So we're just going to test that it works now by blowing it with our fan. There we go. So we know it all works now. What we need to do now then is carefully, if we take the wires out, it'll be easier. We're going to carefully pull the wires back through the mouth, gently, gently, pulling the chock block inside the bottle so that all our components are inside. You can see then that I've carefully pushed this inside the bottle. And you just need to be careful when you're doing this, that you're not being so rough that the wires are going to come out of the chock block. Now once we're in, we want to get our motor in the neck of the bottle, but we want a good bit of the motor sticking up. We don't want it all the way in, because the chances, the likelihood of the turbine head hitting the top of the bottle will be very high. So we want it quite high, like this. And then what we're going to do, if we take off the head, the turbine head, we're going to get our black tape now, and we're going to tape up our electrical tape, and we're going to tape up the top of this bottle just to secure this in place. The thing you want to be aware of though is you don't want to have too much tape over the top, because the turbine head, well, the propeller head rather, will catch. Let me show you this one. You can see on this one all that scraggy tape. Well, what that means is when the children are putting on the head, it catches on the tape and they don't get a very good reading. So we want to make sure we do quite a neat job here. There we go. You can see I've taped that on, but I've kept the tape clear from the top of the motor. Now the last thing to do is we're going to fold the wires over like this, still leaving them a bit baggy. Okay, so we've not got tension in the wires here. We don't want this connection to be pulled. So we're still having it nice and loose, and we're going to tape them on here. Now the reason we're doing that is just in case the wires get yanked by mistake by an enthusiastic pupil. That will save the connectors from being pulled out of that block. If that happens, you're going to have to take everything apart and reconnect the wires. So this bit of tape that we put here is really just going to be to stop that from happening. So you can see I've done that on this one. Okay, I've just got this tape in place here. Here we are, you can see it here. And for the black one, and all that means is if the child gets excited and gives those wires a pull, it's not going to be pulled out of the chock block at the top. Okay, so once you've done that, you have made your wind turbine and it's ready to start your fair testing. So it's time now to actually start the activity with the children, but how are we going to set this up so we get the most learning out as possible? Well, the first thing I would suggest to do on their blank recording sheet is I would get them to predict which turbine head, which propeller head do they think is going to give the biggest yield, which is going to produce the most energy when it is blown by the hairdryer. And all I would get them to do is in the recording box draw the propeller heads in order from what they think will be strongest to weakest. And you'll probably get something like that, I think. And then you can have a discussion about predicting, well, why do we think that? You have a discussion in groups or in partners or as a whole class. You can have that discussion with them. So they're making a prediction and they're justifying their answer. Now, before you go let them loose doing their recording, I would suggest spending a bit of time to establish how can we make this a fair test. So for example, if I was to get this and put the turbine on, and then I'm going to blow it with my hairdryer, if I blow this close for this turbine head, this propeller head, but for my next one, oops, for my next one I'm busy listening to what my partner's saying, and I stick the head on, and I get a bit distracted, and it's more over here, we're not going to be getting a fair test. So ask the children, what can they do to make sure it's a fair test? Maybe they're going to suggest that one partner holds the wind turbine and the hairdryer, while another person holds a ruler underneath, so they can make sure it's always blowing at the same distance. Maybe you want them to think about angle. Does it make a difference if you blow straight on or to the side? So again, a ruler could be a good idea, because you can make sure you're in line with the ruler and at the same distance, so you're getting the same reading. Does it matter how long you let the wind blow for? For example, would the yellow turbine take a long time to speed up, but actually once it gets there it produces a high yield? The black one maybe gets fast very quickly, but actually give it a minute or two, slows down. I don't know, maybe the children need to think about that. So those are their different variables that they want to be controlling: the distance from the wind source, the angle of the wind, how long is exposed to the wind. And that way they know that the only thing that's changing, the only thing that's changed every experiment, every test, is actually the propeller. So there we go.